Web workers are a way to exploit the CPU's cores available. If you have a web application that requires a lot of computing power, it is a great way to tap an unexploited resource. You need to understand that all your JavaScript code or Java code compiled by GWT is single-threaded. The browser executes everything you program when the main thread is available. For example, setTimeout is only fake threading. If you have a computationally intensive piece of code, it impacts everything. Asynchronous treatments, event handling, everything. Hence, you should move the code that requires more CPU resources to web workers. Web workers are effectively independent processes running in the browser. The problem is there was so far no convenient way to do it with GWT. If you have tried it before, you have found that you need to employ a custom linker to compile your web worker. However, if you do that, you cannot use superdev mode, and you have to keep your web worker separated from the main application. I decided to have a look at that because I needed to run an algorithm called Monte Carlo tree search, and, as you guessed, it uses the CPU a lot. Fed up with the limitation of the standard cross-site iframe linker, the only linker that works in superdev mode, I started playing with the JavaScript templates it uses. Soon I was able to make it work. Therefore, I could deploy both my main application and its web workers alongside, in superdev mode. Now, a demonstration. The main application starts by displaying a message in the console. Then, we instantiate a worker by putting the script file name. The worker class is a native class, which will provide access to the browser's web worker API. The constructor with the web worker's script URL. PostMessage is the function we have to call to send a message to the web worker. And addEventListener will allow us to get the message from the web worker. Here, we use it to display the message from the web worker. Finally, we send a message to our worker. The web worker is an entry point with an onModuleLoad method to override. The web worker logs that it is running. And we listen to messages from the main application. There is no window nor document object in a web worker. Instead, we have a dedicated worker global scope object. We use JSInterrupt for this native class. And, as in the worker class, we have addEventListener and PostMessage. addEventListener will allow us to get the messages from the main application. PostMessages will allow us to post messages to the main application. By the way, there is nothing special with the native console class. Both the main application and web workers can access the browser's console. Then, the web worker logs messages from the main application. And the web worker sends one message to the main application. We start the superdev mode. After a quick compilation, we get the reference error. There is no window object in the worker. The error comes from the JavaScript files GWT generates. I stop the program. And I will copy the patched jars to my GWT folder. I restart the GWT superdev mode. By the way, the Qt XML file for the main application is elementary, and the one for the web worker is straightforward too. No custom linker. And it works! Both the main application and the web worker load. Both sent a message to each other, and both received the message from the other one. You will get the example on my website. You will find two Qt 2.8.2 patched jars on Xalys.com, so you can play with it too. There is a link below the video. And I will see how to integrate it directly to Qt. The only thing that is not working yet is the source map of the web workers. Anyway, to be able to use web workers efficiently in Qt is an invaluable addition. Even more since service workers finally landed in Safari. Thanks for watching!